Okay, this video I'm going to combine a couple of different concepts. The first concept we're going to talk about is how to convert degrees, angle degrees into radians. The second concept is how to find arc length based on the circumference of a circle and the central angle measure. And then the next one is going to be how to find the area of a shaded sector. So the first thing is we learned today in class, we did a proportion, and the next 3 lessons will all be proportions. And I am going to find radians over pi is equal to angle measure over 180 degrees. And this all stems from the fact that, and this is just the definition of radians, that pi in radians is equal to 180 degree angle. So if I have a semicircle and I want you to tell me the degree of the semicircle in radians, that degree in radians is going to equal pi, or 3.14. So knowing these things, and this is kind of the really important formula that we talked about today, or relationship today, is when I'm finding degrees, I'm going to be searching for radians over pi is equal to some angle measure over 180 degrees. And here I'm just going to use my calculator, and I'm going to have the cross product, so I'm going to have 180x is equal to 12 times pi. And I'm going to leave these in degree of, or I'm going to leave these in terms of pi, so I'm just going to simplify from here. And whenever I simplify, 12, and clear it, 12 pi divided by 180, I'm not going to give it in decimal form. I actually want it to be as a fraction, and I know that this is going to simplify to pi over 15, and so this would be my answer in degree radians. Number 2, it's kind of the same situation, so I have x over pi is equal to 180 degrees over 180 degrees. And in this situation, some of you questioned it today, is that this is going to equal 1, so x is just going to equal pi, and that's by definition what x is equal to. So the next situation, x over pi is equal to 225 over 180. And I like this situation because here we actually have where it's going to be greater than pi, so, or greater than 1, because 225 is greater than 180 degrees. So I am going to take 225 pi and divide it by 180, and it's going to give me a decimal, but if I press the arrow button here, it's going to give it to me in simplified form, and that's going to be 5 pi over 4 is equal to 5 pi over 4, and that's just by dividing out 180. So that's a little bit about that situation. Now we also have where we're converting radians to degrees. So if I have radians, I'm going to have 2 pi over pi is equal to some angle measure over 180 degrees. So in this situation, it's just 360 is equal to x. So 2 pi is equal to 360 degrees. My same situation here, I have 11 pi over 6 divided by pi is equal to x over 180. And whenever I have 1 in the numerator and 1 in the denominator, it just becomes 11 over 6 is equal to x over 180. So in this situation, I just use my calculator, 180 times 11, and divide it by 6. And so my angle measure here is 330 degrees. And you continue on using the same type of situation. So that kind of covers converting angle measure into radians, or converting radians into angle measure. The next type lesson that we're going to cover, and we're covering it very quickly, is that we're going to find the arc length. So that means the length of AB, and that's going to be changed because my radius is 5 meters in this situation. So we had a certain formula. So we had arc length, different than arc measure, over the circumference of my circle is equal to the arc measure in degrees over 360 degrees, which is my whole circle. So in this situation, I have arc length, and then I'm going to do 2 pi times r, which is 5, radius is 5, is equal to 150 degrees over 360. And so then I just set my cross products equal to each other, and I have 2 times 5 times pi times 150. And I want this in decimal form, so that's going to equal 4,712.39, and I forgot to say 360x, and then I divide it by 360, my answer, and so x is going to equal 13.1 meters. So my distance in meters from A to B is going to be 13.1. And I continue to solve it the exact same way. The only situation that might be different is the fact that I might be given the circumference, or I might be given the diameter. So in this situation, I have arc measure over 2 times pi times 6 is equal to 40 over 360. I set the cross products equal to each other, and that's 2 times 6 times 40 times pi, and that's going to equal 1,507.96, and divide it by 360, and so x in this situation is 4.2. The length is 4.2 feet. So that kind of covers arc length and how it relates to circumference, but it all comes back to knowing this one formula, which makes sense because it's part of the arc over the whole circumference, is equal to the arc measure, so the part of the arc that I'm trying to find, divided by 360, which is our whole. So the next type of situation is what we covered today in class, and that's the sector area. So in this case, I'm going to use my area instead of the circumference. So I'm going to say area of a sector. So this part of that's shaded, and that would be this part over here, divided by the area of the circle, because that's the whole area, is equal to the central angle, or the arc measure, angle over 360 degrees. So it's the same type of situation that we used before. So the area of the sector is going to be x, and in this situation it's pi r squared, so 10 squared, is equal to 160 divided by 360. So I have 360x is equal to 160 times 100 times pi, and that's going to equal 50,265.5, and I divide both sides by 360, and so x is going to equal 139.6 inches squared, whereas my whole area of my circle is going to be 314, so it's 10 times 10 times pi. So it's fairly reasonable to say that this angle, this sector here that's shaded, is going to be part, so 139.6 inches squared, of the whole area of 314.2 inches squared of the circle. So here, if you look at number 11, it's a different scenario. I'm given the area of the whole circle. So I'm solving for the area of the sector, and the area of the whole circle is 36.07. And I'm given that the essential angle is 58 over 360. So I take 58 times 36.07, and that is going to be 314.16 is equal to 360x, so divide that by 360. And so x is going to equal 5.8. So my 5.8 centimeters squared, the area of my sector here is 5.8 centimeters squared. So that gives you a little insight as to what we did today in class.